who is she? Whole world.
Hello everyone. I hope you are doing well. My name is Sayam and welcome back to the channel. Right, today we're gonna solve this interesting problem of minimum penalty for a shop. And this problem I would rate 7.1 out of 10. We are not mustering. So they have a method to calculate the penalty for every hour when the shop is open and there is no customer. Means you're wasting the resources. That means what? You have to increase the penalty by one. Means you have to count one penalty for that hour. Other cases, you can close the shop. And let's say some customer comes. That is also a waste of resources, right? Like it's not a waste of resources, by the way, but you're not utilizing your resources because customers are there. You're not opening the shop. So every hour when the shop is closed, then customer comes, the penalty increases by one. Okay. Return the earliest hour at which the shop must be closed occur a minimum penalty. Yes, that means what? Obviously, want to minimize the penalty as low as possible. So you have to find optimal time when you should close the shop. Okay, very important. But if a shop closes at the JR, it means the shop is closed at J. Means you will consider at that point of time instantly you will close it. You are just magician or some genie that at that point of time only the shop will be closed. Perfectly fine. Perfectly fine. Let's try to see with the help of an example. Let's say this is an example. Y, and Y. So let's say at zeroth hour, you close the shop. What will happen? So that's Y, it's N, and it's Y. That means what? This is a penalty. This is a penalty. This is not a penalty because no customer is there, and this is a penalty. You got a 3 penalty. Let's say you close the shop at first hour, you close it here. So this here the shop is open, till here the shop is closed. But why is there? Means there is a customer. No problem, no problem. So there is no penalty from this side. Here there is a penalty of 2, right? Because Y and Y, there are 2 customers, but you have closed the shop. Cool. Now let's try to close the shop at this point of time. At this point of time. So here 2 is there, no problem. Like 2 Y's, customer's shop is open, no problem. Here there is one customer who comes, so you have to mark it as 1. Like there is 1 penalty from this Y. Cool. Now let's say Y, N, and Y like this. So what will happen? So here there is no penalty. Here is a penalty because the shop is open but there is no customer. Here also the shop is closed but there is a customer. 2 penalty. Right. And the last case is Y, and Y. You shop close the shop at this point of time. See, you have 3 customers, no problem. But there is a time where there is no customer and means 1 penalty. So there are 2 times there is a 1 penalty. R2 as well and R4 as well. Since we want to return the earliest time as possible, so what we will return? We will return 2 is the earliest possible. That is the overall idea. Okay. From this, what you get the intuition? Sayam, let's try to see the constraints. What constraints told us? Constraints told us very bad thing that we have to solve it. O of n time 10 power 5 is there. So O of n we have to solve this problem. See, what is the worst thing you can do? If you can try out all the possible time zones, right? This is the intuition you might get. And but if you can do this in optimal time, that is the overall scenario. Means we want to try. Obviously, we want to try. We want to try all possible time for the closing time. So can we optimally calculate for that closing time? And we want to calculate the minimum penalty from wherever we will get the minimum penalty. And if they are same also, the logic remains. Whoever comes first, the earlier hour, that we will consider as the time. We remember that we don't need to return the minimum penalty. We need to return the earlier hour, the earliest hour possible. That is very important. That makes the question slightly interesting. Minimum penalty. Okay. We don't need to remember the penalty. We need to remember the earliest time. Time is important. Okay. So from this example, what we are like concerned about, we just concerned about the counts of the customers. If we somehow know the count of the customers for opening while opening the shop, for like while opening and while closing, then we can do something interesting. If we know optimally these things, like opening the shop, we know, and closing the shop, we know how many customers visited. Then can we calculate the penalty? Let's say while opening the shop, there are X customers, and the total hours is let's say H1. And let's say while closing there are Y customers and the total hours is H2. Right. Can you tell me the penalty from where there? It's simple mathematical calculation. The penalty would be what? The penalty would be total penalty would be firstly penalty from opening total hours passed are H1 minus X because there are some hours there is no customer. That means that is the penalty. Plus here try to understand that Y customers are there. Y customers are there. That means what? As many customers, as much penalty. So Y. So it will be H1 minus X plus Y is the penalty. Now the important idea is how would you find this X and Y optimally? H1, H2 to H9. X and Y, how we can find it optimally for every partition? Can we do something? Oh, for after getting this, Sayam, we got an intuition that what we are eventually doing, we are going one by one, checking each time as an earliest time possible, calculating the penalty. So what we can do, we can maintain a perfect counter. Oh, right. Like how many customers? See, X is very easy to calculate. What is it's very simple, right? You just need to calculate, you just iterate in the customers array, and if you found a Y, that means increase the count of the customers. Absolutely right. That means you can easily maintain prefix and calculate X. But how would you calculate Y? That is a good question. Like how many customers are remain are like on after after the shop closes. Like, let's say you consider at ith instant you close the shop. You have to calculate how many customers are come in this interval. You know from this interval easily from prefix. Here you need to think about how you can calculate it. Now you have to just apply a simple logic. I hope many of the people got it. It's nothing but you can do a total minus this prefix. Right. That will help you, right? Because total, let you calculate initially the total number of customers beforehand in one loop, and then you can just minus the current prefix count of the customers, and you can get there. Let me just show you with the help of an example also. Let's say this one. This is y, and y, and you maintain a prefix count. So here initially it is 0. Initial prefix count is 0. Now total remaining customers are what? 3. Then you come here, you get 1 and you get 2. Then you get again 1 and 2 because here, here you got 2 and you got 1. And then here it remains 0. It remains 2 and it remains 1 and then it's 3 and it's 0. Right? It's like 0 to n times 10. So it's 0, 1, 2, 3 and 4. After that, completing that. Initially, I'm at this time instant, then this, then this, then this, and then this. Like this I'm going. Okay? So 0, 3. This is the, you can say, the count of the customers before closing and after closing. Okay, so yes, we can maintain that. So we can easily calculate this total. I hope you're getting it. Just run a loop and calculate wherever is a y, increase the total, you got the total. And you can maintain the prefix in a similar way that you got currently iterate in the prefix and then calculate the prefix and then you can calculate y from here. Then you can calculate the penalty from here. And what you want to do? You just want to minimize it. You just want to minimize it. To minimize it.
Wait a minute. You used to be the last to leave person. Now you are done before everyone.
Yeah, I attended the 3 RAI.
So just you can maintain two variables, a mini, you can say min penalty. So you're very interested in full debate. And the time, in this case. But let's say your interval in so 1 minus x standard. You just need to consider about the R, 2 and 4 because that remains same. Right now, how we can do it? See, it's very simple. It's very simple. Why? Because we are considering the current R. Penalty is larger than curr penalty. That means we need to update our min penalty to curr penalty, and just update our time. Importantly, I plus 1, not I, because we're cutting it. Plus 1 in sense, VR I equals to 0, but I plus 1 in sense time will be updated like that. Yeah, again got a y, will decrease it. Will decrease it. That becomes minus 2, or meaning becomes minus 2, and the time also becomes 2. Right? Now we got a m. We will increase our curr now. Why? Because this is now considered as a penalty, it becomes minus 1, mini remains minus 2, time remains 2. We got a y again, so we decrease it again with minus 2, mini remains minus 2, time remains 2 only because this is we consider the earlier time first. That is the idea. Let me quickly show you the code also. So this is the implementation. It's very simple. Maintain 3 variables, maintain the size. If you got a y, that means what? You increase the curr penalty, you decrease the curr penalty. Otherwise, you have to increase the curr penalty if you got an n, and just compare it and the time. And I explained you why it works. Very important. Many of you have read the solution, but why it works, the intuition, the detailed intuition I explained you.